Hi, Mary. I'll walk you through these problems that you sent me. So first of all, let's look at number 2. A box contains 5 plain pencils and 3 pens. A second box contains 3 colored pencils and 3 pens. One item from each box is chosen at random. What is the probability that a plain pencil from the first box and a colored pencil from the second box are selected? Write your answer as a fraction in simplest form. All right, so, and I might use this area down here so we have enough room to work on this. So, this problem is talking about 2 separate boxes. So, that means it's an independent event. The first event and the second event don't change each other. So on this one, we want to look through and see what we have. So a box contains 5 plain pencils and 3 pens. The first box does. The second one has 3 colored pencils and 3 pens. One item from each box is chosen at random. So first of all, we need to find out how many items are in each box. So in the first box, there's 5 and 3. So that means that there are 8 items in the first box. And in the second box, there are 3 and 3, so there's 6 items in there. And so now it says, what is the probability that a plain pencil from the first box, so plain pencil, so there are 5 plain pencils, so we want to put 5, so the probability of pulling a plain pencil from the first box is 5/8. So, and then what is the probability that a plain pencil from the first box and a colored pencil from the second box? So there's 3 colored pencils in the second box. So the probability of pulling a colored pencil out of the second box is 3/6. So then what you want to do when they're independent variables is you just multiply these together. But I need to make sure I can't reduce anything here, which I know I can reduce 3/6 to 1/2. So basically for this problem, what you want to do to get your answer is you're going to take 5/8 and times it by 1/2. And then if you need to reduce anything, do that, but that will give you your answer. So finish working out that one for number 2. Okay, number 3. Let's see, we'll do this on the green. So a bag contains 10 marbles. 2 are green, 4 are red, and 4 are blue. Felipe chooses a marble at random and without putting it back, chooses another one at random. So right there, that tells me that this is a dependent event because he did not put the marble back. So that means in the second fraction, 1 got taken away. So what is the probability that the first marble is blue and the second is green? Write your answer as a fraction. So let's see, let's come over here, number 3, sorry. And let's see how many marbles. The first bag contains 10 marbles, so that's my denominator, 10. And let's just get the second one really quick too. Okay, and so then, well, let's go over the first one first, sorry. So what is the probability that the first marble is blue? So we want to know what's the probability that the first one would be blue. So when he has all 10 marbles in the bag, 4 of them would be blue. So the probability of picking out a blue one would be 4/10. And so now when it's a dependent variable, it says, what is the probability that the first marble and the second is green, but he didn't put back that first blue one. So now we're down less 1 blue one. So now there's 9 total marbles in the bag. And 2 of those are green. So the probability of picking out a green one the second time would be 2 out of 9. Okay, so then I can go through and reduce what I need to. So 2 can go into both of these. So that would be 2/5 on that one. And I can't reduce 2/9. So, and then multiply that by 2/9. And that would be your answer. So for number 3, that's what you want to do. to get your answer and make sure that it should be reduced as much as it can. Just double check that each time, because every time it's saying to do it in simplest form. Okay, then number 4. Let's find another color so that it's not too confusing. Okay, so number 4, a bag contains 10 marbles. 3 are green and 5 are red and 2 are blue. Mary chooses, oh, good to see it's got your name in there. Mary chooses a marble at random. Without putting it back, chooses another one at random. What is the probability that both marbles she chooses are red? Write your answer as a fraction in simplest form. So the fact that it says without putting it back tells me again that this is another dependent event, which basically just means the second fraction that I have in these problems will be 1 less. The denominator will be 1 less than the first fraction. Okay, so the second one, she has 10 marbles, and it wants to know what is the probability of choosing red both times. So there's 5 red the first time, but then the second time, since she already pulled out one, if she already had pulled out one of the reds, then there would be 4 red left in there. And so now there's 9 marbles left, and 4 of them are red for the second one. So again, you want to reduce if you can. So we can reduce 5/10 to 1/2 and then multiply it by 4/9. And let's see. Oh, and we can reduce these two as well, which would probably give you your answer. So, because I can reduce the 2 and the 4, so then it would be, that one would be 2. So your answer should be 2 out of 9 on that one. Okay, so that one's number 4. Sorry, this is looking like a huge mess. Okay. Then, so we've left ourselves a little bit of room for number 5. Number 5 is just a review. You should be able to know this one, but let's see. So remember, triangles always just equal 180. So I just need to take these two numbers and subtract them from 180. So I could add them together to subtract them from 180. So if I add 67 plus 54 together, I get 121. So that part equals 121. So I'm just going to subtract 121 from there. And then whatever I get there, that should be my answer. All right, so I hope this helps. Again, if you have any other extra questions, sorry, this is a huge mess. But you can, let's find. So this one right here would be number 2. You just need to finish that part. This one over here would be number 3. This one right here is number 4. And then this one right here is number 5. Okay, let me know if you have any other questions. Thanks.